La 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 la. Now, firstly, I would like to introduce you to Chapter 7, Unsolved Mysteries. Now, whatever you are, much of physics, and I'm not even mentioning science in general here, is about wondering how and why things happen. And much we understand about this thing is just because we can answer those questions with series, or it's much about how we understand our world and the universe we live in. And there are technically details that we simply do not understand at all. Although some people say, I don't care about these details. I don't need to know these details to keep living. Yeah, but wouldn't it be fun if you did? No, because I do not like science. And so, with that in mind, whether you're in a lab running experiments, or a computer analyzing data, or simply observing the world around you, you're doing physics, science, and you want to know what everything's made of, and why things happen, and why they do, and that's a good thing. And if you keep going and doing that, and it just sounds interesting to you, then you could be a physicist. Personally, I want to be an educator. Space travel! Now, space travel is basically one of the unsolved mysteries. Sure, we have rockets, but how do we go to the other stars? Now, there are 4 prototypes that we've thought of. The nuclear fusion engine, but with our current technology, it can't do anything much because, well, we need more energy to create less energy. Yeah. It can go about 10% of the speed of light, cutting the journey time to Proxima Centauri into 42 years. So, but right now it's unclassified. Next thing is the beam power propulsion. The good thing is there's no need for fuel. Yay! Bad thing is, how are we gonna get this big darn thing into space? Build it there? No thank you. Our next one is the antimatter drive. The pros is that it can go 90% of the speed of light. Yay! And the fuel is antimatter, but scientists currently have no idea how to store antimatter in this amount of quantity needed, and safely too, because every container that can think of is made of matter, and if you attach one antimatter onto you, then one of your atoms will basically die. So that is a bad idea. And just before that, we still have no idea how to make this much antimatter, at least in a safe way. And the last one is the Alcubierre warp drive. Sounds like Star Trek or Captain Marvel, doesn't it? Well, it's basically a portal. Like, it can cut journey times down to a matter of hours. It's basically creating a wormhole, so it can go ahead to other places you want. And that you could use that to take a shortcut. You remember Einstein saying that it's like a fabric, right? Well, technically you could like fold the fabric and then cut a hole through it. Then the little flaps that come down, you connect them together. Then you basically created a little shortcut. You go through there, and yeah. Now there's problems with that. You can technically time travel too, but 1, no one's ever found a wormhole. 2, we have no idea if you could survive one. 3, it's very improbable we could find one. Also, you need to be big enough to stretch down one too. So, spaghettification it is. Yikes. Now, matter and antimatter. Now, like, this is an electron, this is a positron. It's the opposite of it. And then the proton would have a negatron on it. So, everything seems to be the same. And if you smash antimatter with matter, and they're the exact same opposite charges, then they'll annihilate each other and shoot out 2 photons. So where is all the antimatter? Well, technically it was said that the universe should create equal amounts of matter and antimatter. Well, then nothing would have existed. Well, matter and antimatter happened, and then matter won over antimatter. So antimatter exists here, but more or less like survivors of the original universe. It's like the Kree Empire and the Skrull, where the Kree just destroyed all the Skrulls, and the only remaining Skrulls are the refugees. So what is the universe made of? 5% of what we're basically seeing we can touch, and we're certain we have known for the thousands of years, is only 5%. It's ordinary matter. Well, 27% is something scientists call dark energy. Dark energy, dark matter. And 68% is something else that we can't quite know what it is. We use dark matter to explain why galaxies spin and why star systems are still there and not pulling each other away. We can even use that to actually talk about the expanding rate of the universe. And then people have been trying to marry general relativity and quantum mechanics for a long time. And they've absolutely failed because if you try to do them at the same time, you are basically having several problems. Even though this one describes the gravity of planets and galaxies and massive objects in the universe, this one is able to talk about tiny particles. However, if you try to talk about each of them, like talk about this and this and this and this, you're basically breaking maths. And that's a problem because these two work really well. And they cannot be separate because they're talking about the same things, just in different ways. And one way people thought it could work out is string theory. String theory is actually pretty good with the maths part, but in physical reality, I'm not sure it even exists. No one is. So would you like to know more? And would you like to build a better world? I mean, these are several questions related to the subjects of science or even actual things that happens towards people in their real lives. And I've actually read all these questions myself, and some of them are pretty interesting, and I've googled some of them up and I've got weird results. So yeah, so I really hope you guys enjoyed this episode. Hanchun Chun. I hope to see you guys soon in another episode of Hanchun Chun, and until next time, Shunan out. Peace. How to do physics yourself. All you have to do is ask questions. You don't actually have to do these things. Light, just refract a glass of water. And then forces, build a paper plane that can fly without need of flapping. Static electricity, use it to be able to clean air pollution. Relativity, think about time travel. Quantum mechanics, make a quantum robot if you even figure out what quantum mechanics is. And now it's over to you. So I hope you guys enjoyed this episode of Hanchun Chun. See you guys soon. Next time, Shunan out. Peace. Dun dun dun.